Every time you click a link, fire off an email, or start streaming a show, something pretty amazing happens in the background. It's this invisible, super fundamental process that honestly makes the whole internet even work. We're talking about a secret digital handshake, a little greeting that happens billions of times a day, completely unnoticed.
And when I say it happens a lot, I mean a lot. We're talking thousands of these handshakes happening every single second you're online. It's this silent, constant buzz that connects your device to servers all over the globe, powering our digital world while we're just, scrolling.
So what exactly is this thing? How does it manage to create a stable, reliable connection out of all the chaos of the internet? And here's the kicker. How can something so basic, so fundamental, be turned into a pretty powerful weapon? Let's get into it. All right. To really get a grip on that, we have to start with the basics. In the world of computers, what even is a handshake? Well, at its core, it's basically a digital negotiation. Before any real information can get sent, two devices have to agree on the rules of the road. It's this automated back and forth that sets up the protocols for their chat. Think of it like your computer and a website server quickly agreeing on things like transfer speeds and who talks when, all before the real conversation can start. Now, the most famous of all these is the TCP three-way handshake. This thing is the absolute bedrock for how most of the internet creates a reliable connection. So let's break down exactly how this little dance works. It's this really simple, kind of elegant dance in three parts. First, your computer, the client, sends a little message called a SYN packet. SYN stands for synchronize. It's basically knocking on the door, saying, "Hey, are you there? I'd like to connect." Then, step 2, the server, assuming it's available, sends back a SYN-ACK. That's synchronize acknowledge. It's saying, "Yep, I'm here, I heard you, and I'm ready to connect too." And finally, your computer sends one last ACK packet back, which just means, "Awesome, got it, let's talk." And boom, just like that, the connection is live. So you might be thinking, hold on, that third step seems a little extra, doesn't it? Why do we need that final ACK? Couldn't the client just ask and the server say, okay? Why not just a simple two-way handshake? And the key is right here. TCP is a bi-directional protocol. Communication isn't a one-way street. Data flows both ways. A two-way handshake would only let one side set the rules. But since both your computer and the server need to be able to send data, they both need to send out a SYN to get in sync, and they both need to receive an ACK to confirm they're on the same page. And that process naturally creates these three steps, making sure the connection is solid in both directions. And hey, just as there's a proper way to start a conversation, there's a polite way to end one. That's the four-way handshake, which uses a FIN or finish packet. The big difference, as you can see here, is that starting a connection is a single event, but ending it requires each side to say goodbye independently. This just makes sure no data gets lost while one side is trying to hang up. So, okay, we've got this super elegant, really reliable system for starting and stopping conversations online. But here's the thing. It was designed in a very different time. And that's where we find the twist in the story. This entire system is built on a foundation of trust. This quote really nails it. Back when the internet was just a small network for researchers and academics, security wasn't really top of mind. The whole thing was designed with the assumption that everyone playing was, trustworthy. The system just inherently trusts that anyone who knocks on the door is doing it in good faith.
And that trust is exactly what makes the handshake so fast and so simple. It doesn't need some complex security check just to say hello. But on the modern internet, that trust has become its single greatest weakness.
So, let's take a look at what happens when that trust gets completely abused. How can this simple little hello actually be turned into a weapon? One of the most classic ways to exploit the handshake is through an attack called a SYN flood. And as you can probably guess from the name, it targets the logic of that three-step process directly. So here's how it plays out. An attacker just bombards a server with those initial SYN requests, step 1 of the handshake. The server, just trying to do its job, politely responds to every single one with a SYN-ACK. And for each one, it sets aside a little bit of memory, waiting for that final ACK to complete the connection. But the attacker never sends it. The server is just left there, waiting, holding open thousands of these half-open connections until all its resources are used up and it can't respond to anyone else, including you. It's really like someone flooding a popular restaurant with thousands and thousands of fake reservations. Eventually, the restaurant thinks it's full, and it has to turn away actual customers at the door. The server's own polite, trusting nature is weaponized against it to basically shut it down.
Of course, a vulnerability like that doesn't just go unnoticed. But security isn't the only thing pushing the handshake to evolve. There's also the constant need for more speed. So let's see how this old protocol is being adapted to be faster and smarter.
And this is where it gets interesting, because there's a trade-off. The classic three-way handshake is super reliable, right? But that reliability comes at a cost, latency. Before even a single byte of the website you want can be sent, your computer has to do a full round-trip journey to the server and back. And in a world where we want everything to load instantly, that's a pretty big bottleneck.
So enter TCP Fast Open, or TFO. It's a much more modern extension designed specifically to slash that initial delay. And the secret sauce is a little bit of cryptographic data called a TFO cookie.
And here's how it works. The very first time you connect to a site using TFO, you do the normal handshake, and the server hands you this special cookie. But the next time you visit, your computer sends that cookie along with its very first SYN packet. And here's the genius part. It can also include its initial data request right then and there. If the server recognizes the cookie, it can start sending you the website's data back immediately, basically skipping that whole round-trip delay.
What's so cool about this is that it shows the internet isn't some static thing that was built and finished. Even its most fundamental building blocks, protocols that are over 40 years old, are constantly being tweaked and adapted for the modern world, always trying to find that perfect balance between reliability, speed, and security.
Which, of course, brings us to the big final question. This whole evolution, from a simple, trusting handshake to a faster, more complex system like TCP Fast Open, it shows this constant tug of war. As we demand ever faster connections, and as attackers invent new ways to break things, you have to wonder, in this never-ending race, can security ever truly keep up with the pace of innovation? It's definitely something to think about. Thanks for joining.